We are going to be looking at Lesson 4 from Unit 1, multiplying monomials and polynomials. Okay, we completed page 13 in class. So we're going to move on to page 14 of notes, and we're going to do some more examples. Okay, so with example E, what we want to do, this 2 here shows that we're multiplying 4x to the third 2 times. So we're taking it and multiplying it by itself. Okay, so really we're taking the 4 times the 4, which gives us 16. And then we're taking the x to the third times the x to the third. And we know that we are supposed to add our exponents, so we get x to the 6th. Okay, the name of this would be a 6th degree, because that's our highest degree. And then we have a monomial, because we only have one term. Okay. It looks like we're doing the same thing for part F. So we're taking that, we have that 2 here. So that means we're taking negative 5x and multiplying it by itself twice. Okay. If that was a 3, we'd multiply it by itself 3 times. Okay. So we're going to take the negative 5 times the negative 5. And we get a positive 25. And then we're going to take the x times the x, which gives us x to the 2nd power. Okay, so don't forget that there's like those imaginary ones anytime you have just a variable and don't have an exponent like higher than that. So we add the 1 and the 1 and we get 2. Okay, that makes this a quadratic. And again, we only have one term, so a quadratic monomial. Looking at example G, what this is really wanting us to do is it's wanting us to distribute. So really we could take 4x to the third times 15x squared and 3x times 15x squared. I'm just going to do it kind of backwards. I'm going to take that 15x squared and multiply it by both my terms and my other set of parentheses. So if I take 15x squared and I multiply it by 4x to the third, I get 60, because 15 times 4 is 60. And then my exponents I need to add, so x to the third and x to the second, that would be x to the 5th. Okay, then you still have to take that 15x squared and multiply it by the negative 3x. So 15 times 3 is, 15 times negative 3 is negative 45. And then x squared times x is x to the third, because we can't forget that there's that imaginary 1 there on that negative 3x. Okay, this is in standard form. Our highest degree is 5, so this is a 5th degree. And then we have 2 terms, so it is a binomial. Okay. Okay, let's look at H. So with this one, we have to do quite a bit of distributing. So we're kind of using actually everything that we've really learned so far. Okay, so we're doing this negative 1/2. In front of this set of parentheses, we're going to multiply that negative 1/2 x by everything in my parentheses. Okay, so that means that negative 1/2 x times x to the third is going to be negative 1/2 x to the 4th, because don't forget that one imaginary 1 there. Okay, then we have negative 1/2 x times 4x squared. Well, negative 1/2 times 4, we're just basically taking half of 4, is going to be negative 2. And then we have x to the third. Okay, then we have that negative 1/2 x times negative 2x. So negative 1/2 times 2 gives me a positive 1. And then we have x squared because we have a 1 on that negative 1/2 x, and we also have an exponent of 1 on negative 2x. Okay. Now with this, don't forget, it's like having that 1 there, or that negative 1, and we're going to have to distribute that negative 1 into everything in that second set of parentheses. So negative 1 times 5x to the 4th is just negative 5x to the 4th. Negative 1 times x squared is negative x squared. And negative 1 times 1 is negative 1. So again, it's just like changing all of your signs. Okay. We're not done yet though, because now we have to combine our like terms. So we have negative 1/2 and negative 5 for our x to the 4ths. Okay, so if I take negative 1/2 minus 5, I get negative 11 over 2 x to the 4th. Okay. Then I have this negative 2x to the 3rd, and I have no other x to the 3rd, so I'm just going to bring that down. Then I have 1x squared and negative 1x squared. So basically, if I have 1 minus 1, that gives me 0. So these are actually going to cancel each other out. And I would then be left with negative 1 here that I'm going to bring down. Okay, this would end up being a 4th degree trinomial, because I have 3 terms and my highest degree is 4. Okay, moving on to example 8, you're going to see examples like this often. So I really want to make sure that we understand how to do number 8. Okay, so with number 8, it says find the perimeter of the larger figure. So we're talking about this figure that I've outlined in orange. Okay, that is my larger figure. Okay, so if I want to find the perimeter, that there is a rectangle. So I need to know that opposite sides are equal. Okay, so if this side is 3x plus 3, that means this side's 3x plus 3. If this side is 4x, that means this side is 4x. Okay, and if we want to find the perimeter, we need to add all of our sides together. So we're going to take, I'm just going to put part A here. We're going to take 3x plus 3 plus 3x plus 3 plus 4x plus 4x. Okay, and then we want to combine everything. Since we're just adding, we're going to take our 3x, our 3x, our 4x, and our 4x, and we're going to combine everything. So we have 3 plus 3 is 6, plus 4 is 10, and plus another 4 is 14. So I have 14 total x's. Okay, and then I have 3 plus 3, which gives me 6. So my simplified perimeter of my larger figure would be 14x plus 6. Okay, but then it wants the perimeter of my smaller figure. So this time I'm looking here. The figure outlined in like that orangey brown. Okay, so if we know that our sides are both x here, that means the rest of these sides are also going to be x. Okay, that is a square. All sides are congruent. So if we want to find that perimeter, we're going to say this is part B. We're taking x plus x plus x plus x. Okay, you could have also done 4 times x, and that would have given you the same answer. So we end up with basically 1 plus 1 plus 1 plus 1, which is 4 total x. Okay. excuse me. So then it asks in part C for the area of the larger figure. So we're back to this orange figure. Okay. And if we're back to that orange figure, we want to find the area, which means that we are going to have to take length times width, because the area of a rectangle or a square is always going to be length times width. Okay. So we're going to take this 4x and we're going to multiply it by the width, 3x plus 3. All right. So I have 4x. I'm going to put these in parentheses, times 3x plus 3. Okay, and this is what we learned today. We learned how to multiply a monomial by a polynomial. So we're going to take this 4x and we're going to multiply it by 3x. 4 times 3 gives me 12. And x times x, remember whenever we're multiplying, we have to add those exponents. So it's really going to be a 2. Then we have 4x times 3. So 4 times 3 is 12. And then we have x, and there's not an x here, so that's just going to stay x. All right. So our simplified area of our larger figure is 12x squared plus 12. Okay. Now it wants the area of the smaller figure. So again, we're going back to that like brownish orange figure, that middle figure here. Okay. And we want to find the area of that figure. So again, we're using that length times width. So in this case, our length and our width are the same. It's just x times x. Okay. And that's like having a 1 and a 1 there. So if we take x times x, we end up with x, and we add our exponents to get to the second power. Okay. The last part is the part that trips a lot of people up, because now it's wanting the area of just the shaded region. So we have the big rectangle, and then we basically took away that smaller rectangle, or that smaller square. So if we take that square away, we're actually subtracting. So if I know the area of my larger figure, I'm going to subtract the area of my smaller figure from that. So for part E, what I'm doing is taking that area of the larger figure and I'm subtracting the area of my smaller figure. Okay. So I have 12x squared plus 12. And then that negative 1, yeah, we can distribute that in, but really all that's doing is making it a negative x squared. Okay, and I can combine. So I have 12x squared minus 1x squared, which gives me 11x squared. And then I have my 12 by itself, so I'm just going to bring that down. So the area of just the shaded part of this figure is going to be 11x squared plus 12. Like I said, we are going to see examples like this for a while. So I really want you guys to understand example 8. If we're having trouble, please make sure you're asking questions in class. Okay, so let's look at the last two examples we have here. We have example 9 and 10. So for example 9, it says the side length of a rectangle is 4x minus 5. So let's go ahead and let's draw a rectangle. Okay, and it says one of the side lengths is 4x minus 5. If that side length is 4x minus 5, the side across from that also has to be 4x minus 5. The problem is we don't know this side, which in turn says that we don't know this side. Okay, because it tells us then that the perimeter is 12x minus 4. We want to know what that other side length is. So really, we're saying 4x minus 5 plus 4x minus 5. Now we have another side length that we would have to add in there. So let's say this side length we're adding. And then we also have to add this side length. Okay, and that should equal our perimeter. So hold on, let me make this a little smaller so I can fit everything. So we have plus a blank, and that's going to equal our perimeter, which it tells us is 12x minus 4. Okay, so I'm going to go ahead and I'm going to combine what I can. So I have the 4x and the 4x, which combines to be 8x. And I also have -5 and -5, which is -10. Okay, I'm still going to put those blanks in there. Okay. Now, my next step, what I want to do is I want to figure out what I have left to split between this side and this side. So I'm going to subtract the 8x on both sides. And I'm going to add the 10 on both sides. Okay, so basically these cancel everything out. We have a blank plus a blank is then equal to 4x plus 6. Because I took the 12x and I subtracted the 8x, which gave me 4, 12 minus 8. And then I took -4 plus 10, and that gave me 6. Okay, so now I have two sides that I need to figure out. Those are my blanks. Now, the thing about those two sides is that they both have to be congruent. So they have to be the same. So basically what I can do is I can divide both of these by 2 to figure out what each of these sides is going to be. So if I take the 4x and I divide by 2, I get 2x. If I take the 6 and divide by 2, I get 3. Okay, so that means that this side is 2x plus 3, which then means that this side has to be 2x plus 3. And if I add those together, it ends up giving me 4x plus 6. Okay, so it says, what's the other missing side length? We would say 2x plus 3. Okay. Our next one, we're kind of using the distributive property backwards. So it says find a polynomial that when you multiply it by -2x, you get -2x to the third minus 6x squared plus 10x. So that means that I have 3 terms I need to multiply by. Okay, and if I take, and basically I'm going to divide each of these by -2x. And hopefully you remember your exponent rules from Algebra 1. Because if I take and I do -2 divided by -2, I get 1. Okay, so I have 1 here. And whenever you divide your exponents, you take the 3 minus the 1, which gives you x to the second. Okay, that's whenever you're dividing exponents, you subtract your exponents. Okay, then we have -6 divided by -2, which gives me a positive 3. X squared divided by x to the first. We subtract our exponents, so 2 minus 1 is just x to the first. I'm just going to leave it as x because it's the same thing. And then our last one here, what happens is we take the 10 divided by -2. We get -5. And the x's actually cancel each other out. Okay, so we can say if we multiply by -2x, we can multiply that by the polynomial x squared plus 3x minus 5, and that will give me the answer I wanted. So that negative 2x to the third minus 6x squared plus 10x. Okay, and if you're not sure if your answer is correct, you can go ahead and check by distributing. So if you distribute, you get negative 2x to the third, negative 6x squared, and a positive 10x, which matches, and that's what we want, okay? All right, so that concludes page 15. So that concludes the notes for, I think, what is it, lesson 4 that we're on now? Yeah, so lesson 4, that concludes the notes for lesson 4. If you have questions, please bring them tomorrow.